morning, everyone. Welcome back to Scientific Minds Academy. We have another question up there from chemistry again, which reads: a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molar mass of the compound is 180, find the molecular formula. And in the bracket up there, you can see hydrogen having a relative atomic mass of 1, carbon relative atomic mass of 12, and oxygen relative atomic mass of 16. Now, in the calculation of the molecular formula, we are going to be solving for two different things. First, we're going to find the empirical formula of the compound. Then with the empirical formula, we will now get the molecular formula. So that is the two things we're going to be calculating. So let's solve the question. Now there are three elements there: carbon, hydrogen, and oxygen. And the percentage of carbon is 40, while the percentage of hydrogen content is 6.7, and the percentage of oxygen content is 53.3. Now, first of all, we're going to divide these percentage constituents using their individual relative atomic masses. Carbon is having a relative atomic mass of 12, so we divide 40 by 12. Hydrogen, a relative atomic mass of 1, we divide by 1. And oxygen, a relative atomic mass of 16, we divide here by 16. Now, from my calculation, 40 divided by 12 will give me 3.3333 continuously. So I write it as 3.333. Let me have to 4 decimal places. 6.7 divided by 1 will remain as 6.7. And then 53.3 divided by 16 will get me 3.33312. 3.3312. So this is the reason why I had to take to 4 dp. Now, from this place now, we are going to divide all of them by the smallest. And if you watch, this is the smallest value there. So we divide here by 3.3312, divide by 3.3312, and still divide by 3.3312. If you divide here by this, you will get 1 exactly. Then 6.7 divided by 3.3312 will get me 2.0, which is approximately 2, and here divided by this will still get me approximately 1. So the empirical formula of the compound above is 1 carbon atom is to 2 hydrogen atoms is to 1 oxygen atom. Remember, empirical formula is the simplest formula of a chemical compound, which tells us the ratio of combination of the elements. It doesn't tell us the amount of each element present. It tells us the ratio of combination. Now let's go over to the main question now, the molecular formula. Having had this as our empirical formula, we can say that CH2O, the empirical formula in brackets, then I can introduce a constant here, a variable X, to be equal to the molecular mass, which is 180. Having done this now, what I will do is to substitute again the relative atomic masses of each of the elements, multiplying them by the number of their atoms in the empirical formula. So carbon is having a relative atomic mass of 12. I will substitute in place of carbon. How many carbon atoms are in the empirical formula? 1. I multiply by 1 plus hydrogen, relative atomic mass of 1, times how many atoms in the empirical formula? 2, plus oxygen with a relative atomic mass of 16 times how many? 1. All in bracket multiplied by x is equal to 180. 12 times 1 is 12. 1 times 2 is 2. And 16 times 1 is 16. All in bracket x is equal to 180. Now if I add all the things we have here, I'll be getting 30. Open the bracket with x. 30x is equal to 180. Divide both sides by the coefficient of x. I'm having here to be 30 and here to be 30. 30 takes off 30. X is left. 0 into this, and 18 over 3 is left. 3 can divide itself 1, and 3 can divide 18 to get me 6. Yes, 6. then x is equal to 6. Please substitute x now into the substitute 6 in place of this x in the empirical formula and see what it becomes. We're going to have this bracket again, CH2O. Mind you that this is one atom of carbon, one atom of oxygen against 2 atoms of hydrogen. Please open the bracket now with what you have here. 6 times this 1 will get us 6 carbon atoms. 6 times this 2 will get us 12 hydrogen atoms. And 6 times this 1 will get us 6 oxygen atom. And this comes out as the organic compound which you know very well, glucose, the C6H12O6. This is the molecular formula, and that corresponds with option C in the formula we have. Thank you.